Good morning, good morning, good morning. We'll get started in about a minute. All right, here we go. How'd that homework go last night? Distance formula. First, a couple people emailed me about, what was it, 9 through 12. I gave you a picture of a segment and said, what's the distance? And so the trick to 9 through 12 was, well, you list the two endpoints of that segment. In other words, find the coordinates of where the segment starts and where it ends, and then use those two values to plug in your distance formula. I guess if you wanted to, you could have drawn a right triangle as well too, and just use Pythagorean theorem. Just remember the distance formula is just a Pythagorean theorem in disguise, so to speak. All right, any questions on the homework? Make sure that all gets turned in on Teams. And with that, since it's Friday, remember I just collect homework on Friday. We don't go over the answers. We'll go over answers on Monday and here's the calendar on Tuesday. So on Tuesday we will go over the answers. And tonight's homework is it's a mixture of the distance and the midpoint formula. So if you're unsure of whether you're doing it right, we'll find out on Tuesday. But hopefully after you see this for a second time, you'll be reassured that you are in fact doing it correctly. All right, homework for tonight. It's a couple distance formula, but mostly it's the midpoint formula, a new formula. And just so you know, on Wednesday, we will just do just a wrap up of the distance and the midpoint formula. So we'll just do a practice day for distance and midpoint. And yes, there's a reason we're doing 3 days of this is because it's pretty important. We use both the distance and the midpoint formula, algebra 1 all the way through calculus, and higher as well too, but we use those formulas quite frequently. Okay, here we go. Distance and midpoint formulas. We already did the distance. Today we're going to do the midpoint. The big picture, remember, here's how I sold it to you yesterday. I said, if you have a segment, we can ask two basic questions, which is how long the segment is. The answer to that is, we found out yesterday, use this thing called the distance formula. And remember, it's really just the Pythagorean theorem in disguise. And the second question was, where's the midpoint? That's what we will answer today. So just a quick review on the distance formula to make sure we understand how it works. Well, the distance formula is d for distance is equal to big long square root symbol, the square of the two x values of the 2 points, endpoints, subtracted from each other, plus the difference squared of the two y values. Key points here are the fact that, well, one, it's a big long square root symbol. Don't be lazy and leave off the occasion. I'll see some kids, they won't write the square root symbol. They'll just write what's in the middle, and then they'll say to themselves, oh, we'll just take the square root at the very end. And then they forget to do that. So that's one mistake. A second mistake is that they will forget that there's a minus sign inside of the parentheses, but there's a plus sign between the two sets of parentheses. And then lastly, the most common mistake is you forget to square both sets of parentheses. Okay, so those are the 3 most common mistakes. The fourth one, which is actually the most common mistake, is just simply a math error. There's a bunch of negatives running around, and you simply make one of those quick math errors. All right, hold on a second. I'm getting a chat message that says someone is locked out. I'm not seeing anyone locked out. All right, no, they're here. All right, cool. All right, sorry for that. Moving on. Let's see an example of the distance formula in action here. So you will be given 2 points. Remember, step 1 is the most critical, and that is to label X, Y, and then you got to choose one to be 0.1 and one to be 0.2. Now, this is my method. If you can, I like stacking them. You can write them left and right. Some people will write them left to right. If you see in a lot of books, they will do something like this. So they'll write 2, 1. And then 7, 3, they'll put them left to right. You can use this if you'd like this better. And then what they will do over the top of it is they will write X1, Y1, X2, Y2. And that'll work as well too, okay? I like using this one because of the pattern. Like I said, the pattern is bottom minus top, bottom minus top. This one here, there is a pattern, but the pattern would be these 2 numbers subtracted and these 2 numbers subtracted. And I find that a bit confusing for some students, which is why I like the stacking method. But feel free to use either method. Bottom line is we plug in our numbers. See the pattern, 7 minus 2 and 3 minus 1. And as I'm going from left to right, it just kind of fills in naturally, 7 minus 2. Other people would argue, let's label the first one 0.2 and the second one 0.1, then it's top minus bottom. That'll work. You'll get the same answer. Remember, 7 minus 2 squared is the same as 2 minus 7 squared. It's not true without the square, but as soon as we throw square, because the square of either a positive or a negative number is positive, you do in fact get the same answer. 7 minus 2 is 5. 3 minus 1 is 2. 5 squared is 25. 2 squared is 4. Yes, this is the same one we did yesterday. Square root of 29. And I said you could use your calculators, is about 5.4. Okay, remember, make sure that when you take the square root and it's approximation, that you use approximation symbol, not a perfect square. All right, one more time. Go ahead and write this one down on a piece of paper. Let's do this one for practice. Chime in if any of you are confused or need help in the setting up. Okay. There is the setup. Notice once again, I like this pattern, 1 minus 6, 9 minus 3. You will get a negative on the inside for the first one, but when you square it, that makes it positive. 1 minus 6 is negative 5. 9 minus 3 is 6. And you can see no matter whether it's positive or negative on the inside, when you square it, you do in fact get a positive number. Positive number is important because remember, we are measuring distance. We can't have a negative answer for distance. All right, so 25 plus 36 is 61. We plug that into our calculator. Yes, I did do, whoever's reconnecting, I did do bottom to top, not top to bottom. I said what you could do if you instead, I'm going to write this again, 6, 3 and 1, 9. If you call the first one 0.2 and the second one 0.1, then it would be 6 minus 1, 3 minus 9. Okay. Notice I would still get a 5 instead of a negative 5, but squaring, I still get 25. 3 minus 9 wouldn't be 6, it would be negative 6, but negative 6 squared is still 36. So it doesn't matter which one you do, bottom to top or top to bottom. You still get the same answer once you square. Hopefully that made sense. All right, square root of 61 is about 7.8, and we're done. One more, throw a bunch of negatives. If there's a problem, it's generally speaking when there's negatives involved. Make sure you write it out with all the negatives first before you make any assumptions of how many negatives, what turns into positive, that sort of thing. So yeah, I'm going to use my pattern, bottom minus top. So negative 4 minus minus 1, right? Oops, sorry. Negative 4 minus minus 1. Notice the formula already has a minus sign in it. When both of these are negative, you're going to have 3 negatives floating around, right? 3 negatives. The first negative is from the formula itself. Remember, we get a negative right here. And then these other 2 negative numbers come from the fact that both of these numbers were negative. So you wind up with 3 negatives floating around. On the second one, the 3 was positive, but the sign was to subtract the 2, which is why now there are 2. If you have to write it really small, let's see, -4, 2 negatives turn into a positive, that'd be -4 plus 1. Same signs over here means you add. These are opposite signs. That means we're going to subtract. -4 plus 1 is -3. We're adding over here because the signs are the same. And once again, it looks like we're going to get negatives, but when we square them, that becomes positive. -3 times -3 is 9. -9 times -9 is 81. 9 plus 81, that's 100. That's 100. That's 90. It's a Friday. And the square root of 90, not a perfect square. Well, that would be bigger than 9, but less than 10. And it's what, 9 away from 9, and it's 19 away from 10. So it's certainly closer to 9 than it is to 10. All right, questions? All right, cool. Moving on. Let's just do one. I'm not going to do any work here. I'm going to let you do the whole thing all by yourself and see what we get. I'll pause for a minute and then I'll start plugging in numbers. You can't ask a question if you need help. Okay. Plugging in the numbers, we got lots of negatives floating around here. So -1 minus -3 and 6 minus -3. Wow, that's a lot of negatives. Remember, 2 negatives turn into a positive. So this first one is really -1 plus 3. And the second one is 6 plus 3. 2 negatives make a positive. -1 plus 3 is 2. 6 plus 3 is 9. It gives me a 4 and an 81. Apparently we like 81 today. 4 plus 81 is 85. Let's see. Squeeze that one. That would be 81 and 100. 85 is 15 away from 100. It's only 4 away, so it's really close to 9, but not super close. So it's not going to be 9.1. So if I had to guess 9.2 or 9.3, I'd pull out a calculator. Ends up being, let's see, square root of 85 is 9.21. That would be rounded to 9.2. All right, there's your quick review on the distance formula. Any questions? Questions? A whole bunch of silence. Well, that could either be good or bad. Good if everybody understands what's going on. Bad if you actually have a question you're too afraid to ask. All right, don't be afraid to ask questions if you need help. All right, a couple of these tonight for homework, just as further practice, but we're moving on to the main point of today's lesson, which was the second part of that original question. Remember, I had 2 questions from yesterday, which was how long is the segment? And the second part was where is the middle? So we are going to get that answer from another formula, right? It is different than the distance formula, but it kind of has some similarities with it. So you can certainly, when you're first doing this for the first time in 8th grade, you can certainly confuse the two if you're not careful. But remember, you can always have a resource card labeled correctly. And if you're smart, you have a couple examples written on your resource card to show you how you did those problems. So let's answer the question of where is the middle? So how long is answered with the distance formula, but where is the middle? Pretty easy thing to do here on segment GJ. It's smack dab right there, but it's harder to do on the diagonal one. So where is the middle? We get another formula for it. All right, so the middle, well, we've dealt with middle before in math, right? The middle in math before, well, there is physically the middle, but the question is, mathematically, how do you figure out the middle? So here is the easiest example possible of how you calculate the middle. Well, the middle is basically you take your beginning and your ending, you divide by 2, that finds the middle. Think about it. If you have $10 and $20, where is the middle? 15. Well, that's adding 10 plus 20 and dividing by 2. So if you know where you're starting and where you're finishing, those would be the 2 endpoints. Well, then you just take their coordinates and divide them by 2 after, this is the key here, after you add them together. So I'll say that again. Remember, I mean, here's the example that I just said. Let's say that you start with $10 and $20. Where is the middle between 10 and 20? Well, we already know it's 15, but mathematically, how do you find that? You take the beginning and the end and you add them together. 10 plus 20 is 30. Divide it by 2. Well, that's the middle. And that's the process we're going to use. So the formula will look different than the distance formula slightly, but we're still going to have 2 things floating around. All right. Notice there's no equation here. There's a capital letter M. M stands for midpoint, obviously. And then we have 2 things, because remember, we're doing an ordered pair. And an ordered pair has 2 values. It's going to have an X value and it's going to have a Y value. How do we determine the midpoint? We take the 2 X values. Where am I getting the 2 X values? Remember, you have a segment. So you have a starting point, that's going to have an X and a Y. You have an ending point, that's going to have an X and a Y. So we have 2 X's, we got 2 Y's that are floating around. We take the 2 values, add them together, and divide by 2. Dividing by 2 finds the middle. We do the same thing with the Y value. Notice, we haven't seen this yet in a formula. We got a comma. And that comma, because remember, ordered pairs are written X, comma, Y. That's why there's a comma right here. And then we name our points by capital letters, and by default, M for midpoint. Okay. The M could be actually any letter, but everyone always puts M because you're telling the reader that you found a midpoint. Okay. So that is called the midpoint formula. Pretty simple to do. Does it look like the distance formula? No. I mean, it's got a capital letter M. It's got a comma. Distance formula didn't have that. Distance formula had an equal sign too. This one does not. But it does have an X1 and a Y1. It does have an X2 and a Y2. It does have a 2. The other one had a square. And it did have addition. So we're still missing the minus sign here. That's one of the distance. And we don't have a square root symbol, and we don't have an equal sign. So the first time that you do both the distance and the midpoint together, it's easy to confuse the 2 formulas. All right, so I guess I need to show you how this actually works. Okay, so here are 2 points. We will find the middle of 2, 4, and 6, 10. Where physically is the middle? So what I'm talking about, I don't know, visually or graphically, if I had a graph of 2, 4, 2, 4 would be 1, 2, 1, 2, 3, 4. 2, 4 would be right here. 6, 10 would be 3, 4, 5, 6, and way up here, right? What we're looking for is, if we play connect the dots, right, is where is the middle? Like, what point is right here smack dab in the middle? And this formula will tell us where that point. Let me make it blue so it stands out. This formula will tell us where is the middle of this segment. Here's how it's done. Step number 1, same as with distance formula, label. Okay. Step number 2, plug in the values. M for midpoint, big open parentheses, X1 plus X2. Well, those would be the 2 X values, this time not subtracted, but added together, right? And then I do the same thing with the Y values. And I put a comma between them, and everything is divided by 2. In other words, the X values, the sum of them is divided by 2, and the Y value. Why divided by 2? Because that finds the middle, like the 10 plus 20. 10 plus 20 is 30, divided by 2, 15. 15 is the middle between 10 and 2. Okay, so this one is not too, mathematically it's pretty easy to do. 2 plus 6 is 8. 4 plus 10 is 14. 8 divided by 2 is 4, and 14 divided by 2 is 7. So we get the midpoint is 4, 7. If we look over here in our picture, it would be 1, 2, 3, 4, and then up here is where your 7 is. And that's visually what you're doing. You don't need to graph anything. You don't need to use the graph. I was just showing you visually what we were finding there. So that's the midpoint formula. Questions? All right, as always, best way to learn something is to actually do it. So watch me do one more, and then we'll do some practice. Now, be careful. There could be negative numbers floating around, but it's still the same thing. We're just going to plug the numbers in. After we label, we take the two x values and add them. We're not subtracting them this time. We're adding them. Take the two y values and add them as well, too. So I'm taking the two x values, -3 and 7, and I'm adding them. I'm taking the two y values, 3 and -2, and I'm adding them. And then each one separately I divide by 2. -3 plus 7 is 4. 3 and a -2 would be 1. You will get some answers that could be fractional answers. Don't panic. You can write them as decimals if you'd like. 4 divided by 2 is 2. Well, a half is a half, or 0.5. And there is the midpoint. So the midpoint between this segment AB of these given coordinates is 2, 0.5, or 2, and a half. All right, any questions? All right, let's do one together. Here we go. Take a moment, write down the formula, write down the 2 points, and then let's do this one. When you do your homework, you might want to have the video playing in the background when you get to this point so that you can easily do this. All right, so let's see. The formula says take the two x values. Well, we've got to label them first. Oh, I didn't label them. Let me label them. Label them. So we want to label them x's, and we want to label them y's. So we take the two x values, we add them together. We take the two y values, we add them together. We take each one separately once we get that answer and divide by 2. 2 plus 6 is 8. 5 plus 1 is 6. Stop me if I'm going too fast. 8 divided by 2 is 4. 6 divided by 2 is 3. So we get the point, 4, 3. That is the midpoint of that segment AB. A is at 2.5. B is at 6.1. Halfway between them is 4, 3. Questions? Okay, you guys are awfully quiet today. I know I got about, 11 people in the class. All right, hey, look, I just labeled. All right, let's do another one. I'll pause, give you a chance to write this one down and get started. Got a bunch of negatives here, so be careful. Okay, so midpoint formula is easy. You just take the two x values, add them together. You take the two y values, add them together. I'm answering a chat here. Okay. Take the two x values, add them together. Take the two y values, add them together. So that'd be -1 and a -6. Same signs means add. 3 and a -10, that's opposite signs. That means subtract. That's going to give me a -7 over 2, and that's going to give me a -7 over 2. We get the same number. Now, notice, not a very friendly number, decimal, right? You can leave this as the answer, right? It's fully reduced. Or you can write it as a decimal approximation or decimal number. It's not an approximation, it's an equal. -7 divided by 2 is what? -3.5. So if you would like to write it as a decimal, you can. -3.5, -3.5. Certainly, if you're ever asked to graph this, which you might, right? You would want it written as a decimal, not a fraction. But the fraction is actually a perfectly fine answer as well, too. All right, any questions? Wow, I gotta mark this date on the calendar. The first time that period 3 was ever quiet in class. Amazing. Believe it or not, that was the whole darn class. What time do we get out of here? In 10 minutes, I believe. Yeah, we got 10 minutes left of class. So I'm going to pull up the worksheet. I'll stop this share and I will pull up the worksheet and let's take a look at the worksheet and see if you have any questions on it. So let's see, course 2. This is the worksheet on both distance formula and midpoint. And that would be worksheet number 1. Distance and midpoint formula number 1. Okay, let me share this with you. Okay. So this is what it looks like. So it says distance and midpoint formula worksheet 1. We'll do worksheet 2 on Tuesday. So the first thing it says to do, questions 1 is midpoint. So just make sure you read the instructions. So it says find the midpoint. So we're going to use the midpoint formula for both of these. Next, what it says down here, questions 5 through 8, it says find the midpoint again. Now this was kind of like 9 through 12 on the homework last night, where instead of giving you the actual endpoints, I give you a graph of it. So for instance, on number 5, you got to figure out where is this point and where is this point, and then do the midpoint. So let's see, that first point right there, I'll call it point A. A is at what, 1, -3, 1, -3. And B is at, what does that look like? 3, 5, I think it is. Yeah, that's right, 3, 5. So there are your 2 points, A and B, and now you got to use the midpoint formula. So let's see, midpoint formula. I take the 2 x values, that's 3 and 1, and I add them together, 3 plus 1. Some people will get lazy and start doing this whole thing in their head. Be careful, comma. Take the 2 y values, add them, that would be 5 plus a -3 divided by 2. This one won't be as friendly. Oh no, yeah, it will. 3 plus 1 is 4. So we get 4 over 2, comma, 5 minus 3, that would be 2. 2 over 2. Yeah, we got a nice friendly answer. So final answer, what is our midpoint? Our midpoint is at 2, comma, 1. Now, the nice thing is with a graph, you can confirm it. I mean, I can plot 2, 1. If I plot, I'll do it in blue here. If I plot this point right here, it should be the middle of this. 2, 1 is right here. And notice it's smack dab in the middle. Look at that. That worked. All right. Merry Christmas. I did one for homework for you. All right. Looking further in our form here, question number 9 says distance. So here is your practice on the distance formula. Okay, so practice on the distance formula right here. So 9 through 13. Notice we got 2, 1 on question number 5. And if we look at the answers, 2, 1, there we are. All right. Any questions on anything I did today? All right, got about 5 minutes left of class. I will end it earlier. You guys have a good weekend. Teachers got to work on Monday, but you guys don't if you've got all your homework done. So enjoy all the snow that we may or may not be getting this weekend. And I will catch you guys on Tuesday at the normal time for class. Have a wonderful weekend. See you Tuesday.